get this. There's this new language model, and it's crushing benchmarks like crazy, even beating out, like, the big names, GPT 3.5.
Yeah.
But get this. It's doing it all while using way fewer resources. It's pretty wild.
It's pretty remarkable, yeah.
Right. So today, we're diving into this Mixtral 8x7B. It's like this lean, mean language modeling machine. Why should you care? Well, because this type of efficiency could, like, make powerful AI accessible to way more people. It won't just be for, the big tech players.
Yeah. That's the really exciting part, right? It's like suddenly the playing field is leveling out.
Yeah, exactly. Okay, so let's break down how Mixtral pulls this off.
Yeah.
It's all about something called a sparse mixture of experts model.
Right, exactly. Think of it like, a massive library. But instead of like browsing every single book to find your answer, you have like expert librarians, and they just point you directly to the right section. And so Mixtral does something similar. It only activates the necessary parts of its neural network for each task.
Oh, so it's like having a brain that knows when to focus its energy instead of just trying to do everything at once.
Precisely. And that's how Mixtral 8x7B, with its 47 billion parameters, manages to operate using only about 13 billion actively during inference.
Whoa, that is some serious efficiency. Now let's talk results. We keep mentioning these benchmarks. What are we really looking at here, and just how well does Mixtral stack up against the competition?
Well, we're talking about like standardized tests for language models. So they cover everything from math, code generation, multilingual tasks, even like understanding long, complex texts.
So like the AI equivalent of the SATs.
Yeah, you could say that. And Mixtral is acing those tests and often exceeding, the performance of models significantly larger than itself.
Okay. Spill the tea. Give us some juicy details about Mixtral's wins. Okay.
Well, take mathematics, for example. Mixtral just blows benchmarks like GSM-8K and math out of the water, even surpassing the much larger Llama 270B.
Wait, so it's beating out models that are using all their parameters?
Where?
While Mixtral is just chilling with a fraction of its capacity.
Yep. It's outperforming them with just 13 billion active parameters. So talk about, like, making the most of its brain power.
That's mind-blowing. And it's not just a one-trick pony either, right?
Yeah.
It's handling code generation and multilingual tasks like a champ, too.
Right. Again, Mixtral excels in code generation benchmarks like Humanival and MBPP. And it doesn't stop at English. We're talking superior performance in French, German, Spanish, Italian. So proving its multilingual prowess.
This is starting to sound like the ultimate overachiever of the AI world. So what does all this mean for, like, the average person who might not be a coder or a mathematician?
Well, that's where things get really interesting. Imagine sophisticated language models being able to run on your phone, or being integrated into everyday devices without needing massive processing power.
So this level of efficiency could actually make powerful AI more accessible to, well, everyone, not just giant corporations with supercomputers.
Exactly. The potential applications are vast. Think personalized education tools, smarter chatbots that actually understand you, or even AI-powered assistive technologies for people with disabilities.
Okay, now I'm really seeing the impact. This isn't just about cool tech. It's about, like, changing lives. But let's be real. No technology is perfect. Are there any areas where Mixtral might, fall short or need further development?
Of course. While Mixtral is incredibly impressive, there are still areas where it can improve. One limitation is its reliance on a large amount of training data, which can be a bottleneck in certain scenarios.
So even though it's super efficient, it still needs a lot of information to learn effectively.
Right.
Makes sense.
There's also the ongoing challenge of ensuring that, AI models are developed and used responsibly. We haven't seen any, red flags with Mixtral so far. But, it's something we need to be mindful of as AI technology advances.
Definitely. It's like with any powerful tool, you have to use it carefully and thoughtfully. But those are conversations for another time, right?
Yeah.
For now, I'm just blown away by how much Mixtral is accomplishing with so little. It really feels like a game changer.
Yeah, I agree. It's a significant step forward in AI. And I think its development could spark a whole new wave of innovation.
Okay, so we've covered the basics of Mixtral. Its unique approach to processing information, its remarkable performance across a range of tasks, and even touched on some potential limitations. But we've only scratched the surface. There's so much more to uncover about this groundbreaking model.
Absolutely. In the next part of our deep dive, we'll explore Mistral's ability to handle long contexts. We'll delve deeper into its performance on specific benchmarks and discuss the implications of its open weight design.
Stay tuned, folks, because this deep dive is about to get even deeper.
One of the things that really sets Mixtral apart is its ability to handle long contexts. We're talking about processing and understanding information that spans, thousands of words. Like, think an entire research paper or a complex legal document.
Whoa, that's a lot of information to juggle. Most of us struggle to remember what we had for breakfast yesterday. How does Mixtral keep it all straight?
Well, it's all thanks to, its sophisticated memory and attention mechanisms. And these mechanisms allow Mixtral to keep track of, important information, even when it's buried within a sea of words.
So it's not just reading the text, it's actually remembering and understanding the relationships between different parts of the text.
Exactly. And this ability to handle long contexts opens up, a whole new world of possibilities. Like, imagine using Mistral to summarize, lengthy documents or analyze complex legal cases or even generate, creative content that builds on a vast body of existing knowledge.
It's like having a super-powered research assistant that can sift through mountains of information and extract, the most relevant and insightful pieces.
Precisely. And in our research, we found that Mixtral achieves 100% accuracy in a passkey retrieval task. And this is regardless of the length of the text or where that passkey is hidden.
So no matter how long or complex the text is, Mixtral can still find that needle in the haystack. That's impressive.
Yeah, it is. And its performance on the proof-pile dataset further demonstrates this capability. As the context length increases, Mixtral's perplexity decreases, which means it's actually getting better at understanding the text as it encounters more information.
It's because a student who actually learns more the longer they study. That's pretty rare. Most of us just get tired and confused after a while.
Well, Mixtral doesn't have those limitations. It can just keep learning and improving its understanding as long as there's data to process.
That's incredible. But let's shift gears for a moment and talk about another aspect of Mixtral that you mentioned earlier, its open weight design. What exactly does that mean, and why is it so significant?
Open weight essentially means that, the parameters of the model are publicly available, allowing, anyone to access, modify, and build upon them.
So it's like open sourcing the brain of the AI. That seems pretty radical.
It is. And it has the potential to, revolutionize the way AI is developed and used. By making the model's inner workings transparent, we're fostering, a more collaborative and inclusive approach to AI innovation.
So instead of just a few, big companies controlling the development of AI, we're opening it up to a much wider community of researchers, developers, and even just, curious individuals.
Exactly. This open weight approach democratizes, access to AI, allowing anyone with the technical skills to contribute to its advancement.
That's amazing. It feels like we're on the verge of a new era of AI, where the power of this technology is no longer limited to a select few.
I agree. And with that increased accessibility comes a responsibility to, ensure that AI is developed and used ethically and responsibly.
Definitely. It's like with any powerful tool, we need to use it wisely and thoughtfully. But for now, I'm just excited about the possibilities that Mixtral is opening up. Its efficiency, its ability to handle long context, its open weight design. It all feels so groundbreaking.
It is, and it's just the beginning. As research in this area continues, I have no doubt that we'll see even more impressive advancements in AI.
Well, before we get too carried away with visions of the future, I want to circle back to something you mentioned earlier about Mixtral's performance on specific benchmarks. Can you give us a little more detail about how it stacks up against the competition in areas like, code generation and multilingual tasks?
Of course. When it comes to code generation, Mixtral is achieving state-of-the-art results on benchmarks like HumanEval and MBPP. These benchmarks test the model's ability to generate functional code in different programming languages, and Mixtral is consistently outperforming models that are, significantly larger and more complex.
So even though it's smaller and more efficient, it's still producing better code than some of the heavy hitters in the AI world.
Yes, which is, quite remarkable. And its performance on multilingual tasks is equally impressive. Mixtral has demonstrated superior accuracy in tasks involving French, German, Spanish, and Italian, showcasing its ability to adapt to different linguistic structures and nuances.
This is starting to sound like the ultimate multilingual coding machine.
Well, it's certainly pushing the boundaries of what's possible with AI, and the fact that it can do all of this while using significantly fewer resources is what makes it truly game-changing.
I can't wait to see what the future holds for this technology. But before we wrap up, I want to touch on one more aspect that we haven't discussed yet, the routing mechanism that Mixtral uses to select which experts are activated for each task. Is there anything particularly interesting or unexpected about how this works?
That's actually one of the most fascinating aspects of this research. Initially, we hypothesized that, the experts would specialize in specific domains, like you'd have one for math, one for code, and so on.
Yeah, that makes sense intuitively, right? If you're going to have a team of experts, you'd expect them to have their own areas of expertise.
Exactly. But what we found is that it's not quite so straightforward. The routing mechanism doesn't seem to exhibit, strong domain specialization among the experts.
So what does influence the selection of experts then?
Yeah.
If it's not, domain-specific knowledge, what else is at play?
Well, the research suggests that the routing is more influenced by the syntax and the position of the information within the text.
Wait, so the model is making decisions about which expert to use based on the grammatical structure of the text and where the words are located?
It appears that way. It's a fascinating insight into how Mixtral is, processing and understanding language. It's not just about the meaning of the words. It's about the intricate relationships between them.
That's incredibly nuanced. It's like Mixtral is developing its own internal logic for parsing and understanding language. And that logic might not align with our human assumptions about how language works.
You've hit the nail on the head. And this unexpected finding opens up a whole new avenue for, research and exploration. It challenges us to rethink our understanding of how language models learn and process information.
Yeah, it's a reminder that AI can sometimes surprise us with its ingenuity and its ability to find solutions that we might not have considered.
Absolutely. And speaking of surprises, there's a really cool visual representation of this routing mechanism in Figure 8 of the research paper. It shows how each token in a text is color-coded to represent the expert it's assigned to.
So you can actually see the model's decision-making process in action. That's amazing.
It is. And what's even cooler is that you can start to see patterns emerge. For example, in Python code, words like self are consistently routed through the same expert, even if they appear in different parts of the code. Similarly, indentation tokens in code are always assigned to the same experts, especially at the beginning and end of the text.
So even though there isn't a clear domain specialization, there's still a sense of order and logic to how the model is assigning experts.
Precisely. It's not just random or haphazard. There are, underlying patterns and rules that govern the routing process. And those patterns are revealing new insights into how Mixtral is interpreting and understanding language.
This is all incredibly fascinating, but I'm also thinking about the practical implications. If consecutive tokens are often assigned to the same experts, what does that mean for optimizing, the model's performance?
That's a great question. And it brings up the concept of temporal locality. Essentially, the fact that, tokens close together in time or in the sequence of text tend to be processed by the same experts has significant implications for how we can make Mixtral even faster and more efficient.
Okay, so let's dive into that a bit further. How can we leverage this temporal locality to, improve Mixtral's speed and efficiency?
Well, one approach is caching. If we know that certain experts are likely to be needed for consecutive tokens, we can store their outputs in a cache, so we don't have to, recompute them every time. This can, significantly speed up the processing time, especially for longer sequences of text.
That's a clever way to exploit the model's own internal logic to, optimize its performance. It's like giving it a shortcut based on its own patterns of behavior.
Exactly. And this type of optimization is, crucial for making Mixtral even more practical for real-world applications, especially those that require real-time processing, like chatbots or interactive language tools.
This deep dive into Mixtral has been incredibly insightful. And it's clear that this model has the potential to, reshape the AI landscape. But before we wrap up, I want to touch on one final point. How does Mixtral's performance on certain benchmarks, specific, instruction following, compare to other language models? And what does this tell us about the potential for developing AI that can, better understand and respond to our commands?
That's an excellent question. And it highlights one of the most exciting aspects of Mixtral. Its ability to not only process information, but also to, act on instructions.
So it's not just a passive language processor. It can actually follow commands and complete tasks.
Exactly. And to test this ability, we used a benchmark called MT-Bench, which evaluates a model's ability to follow instructions across, a wide range of tasks.
Then how did Mixtral perform? Did it pass the test?
It passed with flying colors. Mixtral achieved a score of 8.3A on MT-Bench, surpassing the performance of even some of the most advanced closed models like GPT 3.5 Turbo, Claude 2.1, and Gemini Pro.
Whoa, hold on. It beat out those industry giants? Those are some serious contenders in the AI world.
They are. And Mixtral's performance on this benchmark demonstrates its exceptional ability to understand and respond to, like, complex instructions, which is a crucial step towards, developing truly helpful and versatile AI systems.
So what does this mean for the future of AI? Are we talking about a world where we can just tell our AI assistants what to do and they'll actually do it?
We're definitely moving in that direction. Imagine a world where, you can ask your AI assistant to write a report, book a flight, or even compose a piece of music, and it can do it all accurately and efficiently just by following your instructions.
That's incredible. But it also raises some interesting questions about, the role of human intelligence in a world where AI can seemingly do it all.
Yeah, those are questions that we'll need to grapple with as AI continues to evolve. But for now, I'm excited to see what this technology can achieve and how it will shape, the future of our interactions with machines.
This has been a fascinating deep dive into the world of Mixtral 8x7B. We've explored its, innovative architecture, its remarkable performance across a wide range of tasks, and its potential to revolutionize various fields.
Mm-hmm. We've also touched on some of the, challenges and considerations that come with developing and deploying such powerful AI systems.
But before we get ahead of ourselves, I think it's time to take a step back and reflect on what we've learned. In the final part of our deep dive, we'll summarize, the key takeaways, discuss the broader implications of Mixtral's development, and offer some thoughts on what the future might hold for this exciting field.
Stay tuned, folks, because the most insightful part of our deep dive is yet to come.
Okay, so we've spent the last two parts of this deep dive just exploring Mixtral 8x7B, right? We've talked about its unique architecture, its ability to handle long contexts, its impressive performance across those various benchmarks, and even its open weight design.
Yeah, we've covered a lot of ground.
We have. But now I'm curious, what does it all mean? What are the big takeaways from all of this, and how does Mixtral fit into that broader landscape of AI?
Well, I think one of the biggest takeaways is that we're kind of seeing the shift in AI research. We're moving away from the idea that, bigger is always better. And Mixtral is kind of proof that you can achieve remarkable results with a more efficient, focused approach.
So it's not just about brute force anymore. It's about being smarter with the resources that you actually have.
Exactly. And that has huge implications, not just for the future of, AI research, but also for the accessibility and potential applications of this technology.
Right, because if you don't need a supercomputer to run these powerful language models, it opens up a whole new world of possibilities.
Precisely. Imagine being able to run sophisticated AI models on your phone, or having them integrated into everyday devices without needing massive processing power.
That would be a game changer. It would make AI more accessible to everyone, not just those with access to, massive computing infrastructure.
Mm. Exactly. And it could lead to, a surge in innovation, with developers and researchers able to experiment and create new applications that were previously impossible.
This is all starting to sound very sci-fi in a good way. But before we get too carried away with future visions, I want to bring us back to the present for a moment. We've talked a lot about Mixtral's, potential, but what are some of the real-world applications that we might actually see, in the near future?
Well, one area where I think Mistral could have a significant impact is in education. Imagine personalized tutoring systems that can, adapt to each student's, individual learning style and pace.
So instead of a one-size-fits-all approach to education, we could have AI systems that cater to each student's unique needs.
Exactly. And these systems could provide, real-time feedback, identify areas where students are struggling, and even suggest tailored learning materials.
It's like having a personal tutor available 24/7, which would be incredible for students who might not have access to those resources, otherwise.
Absolutely. And beyond education, I think we'll see Mixtral being used in a wide range of industries, from healthcare to finance to entertainment.
Can you give us some specific examples? Paint a picture for us.
Sure. Well, in healthcare, we could see Mixtral being used to, analyze medical records, identify potential diagnoses, and even suggest personalized treatment plans.
Wow, that'd be a huge step forward in personalized medicine.
Yeah, it would. And in finance, we could see Mixtral being used to detect fraud, manage risk, and provide more personalized financial advice.
So it's not just about, making our lives easier. It's about making important decisions, more informed and accurate.
Exactly. And in entertainment, we could even see Mixtral being used to create more immersive and interactive gaming experiences, or to generate personalized music and art.
Okay, now you're talking my language. I can definitely see myself using like an AI-powered gaming buddy or like a personalized music composer. But with all these potential benefits, there are also like some potential risks, right?
Yeah.
That we need to be mindful of.
Of course. Like with any powerful technology, there are always potential risks. One concern is, the potential for job displacement as AI systems become more capable of performing tasks that are currently done by humans.
Right? Yeah, that's a valid concern.
Hmm.
How do we ensure that like everyone benefits from these advancements in AI and that, no one gets left behind?
It's a complex issue, and it'll require a multifaceted approach. We need to invest in, education and training programs that equip people with the skills they need to thrive in a world where, AI is increasingly prevalent. We also need to think about like social safety nets and other policies that can help to mitigate the potential like negative impacts of job displacement.
Like we need to be, proactive in preparing for these changes rather than just reacting to them after they've already happened.
Exactly. We need to have a thoughtful and forward-thinking approach to AI development and deployment.
Well said. As we wrap up this deep dive, I'm feeling both excited and a little bit overwhelmed, honestly, by the possibilities and challenges that AI presents. Any, like, final thoughts for our listeners before we sign off?
I think the most important thing is to, stay curious, to keep learning, and to engage in these conversations about the future of AI. It's a technology that has the potential to transform our world in, really profound ways. And it's up to all of us to shape that future.
That's a great note to end on. Thanks for joining me on this deep dive into the fascinating world of Mixtral 8x7B.
It's been a pleasure.
And to all our listeners out there, keep exploring, keep questioning, and keep pushing the boundaries of what's possible.